my search for a more intuitive explanation for Grover's algorithm that's based on intuition, actually, um, you know, I'm basically restarting that as my intuition obviously failed in my last video. But I think I'm almost there. And I wanted to take a look at. So I wanted to revisit that now for a second with 2 qubits and then take a look at 3 qubits because I think that's gonna help me as well. I have a suspicion that I'm actually awfully close to something that's interesting. So I think with 2 qubits, right, we could do something like that. So let's revisit these. So let's try to revisit the reasoning, right? So the one that was having. So this is we're gonna flag the 1-0 element, and now we're gonna do Grover. Now we're gonna do the amplitude amplification part, which for this particular case is looks like these. And here we go, right? And so the way that I was reasoning about this was saying, you've got, so you basically, at this point here, right, you've got your superposition 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1. When you apply that step in here, you've basically got like 0, 0, 0, 1, and minus 1, 0, 1, 1. So you've phased that element by 180 degrees. And now here's the trick. So usually that first part would expand, right? Like saying like, so it would expand like that. So the term 0, 0 would expand into 0, 0, 0, 1, 1, 0, 1, 1. The term 0, 1 would expand to the same, but it's going to have that element and that element negated. These would follow a similar pattern, but with this element and this element, sorry, and again, already risking some mistakes in here. And this element would basically have this pattern exactly. And so I've been taking a look. So I was reading also a little bit more about so Grover's algorithm. Craig, because Craig has an awesome post which is really old. I mean, it's from 2013, right? But it's just really, and I think that was really the very beginning of the concept for Quirk as well. But he made a comment that basically that basically kind of triggered the fact that I still believe that I was in the right track. Basically says the original value is in so how the magic works. What was that? Exactly. So the original value of your state is now encoded after a Hadamard into the phases of the state. So what this means is, I mean, this is unique, right? Like these elements, this kind of local superpositions here are, before there's any interference, are unique. They're also balanced in a way that they're also balanced. Wait a second. Yeah, so they're also balanced in a way that the interference now would just cancel out everything but the 0, 0 term. So because this is after applying the first Hadamard already of our amplitude amplification. Assuming we haven't really done this, right? And so if you pay attention, there's 0, 0, 1, positive, negative, and then the same happens for all the other elements. Now, really, what the oracle has caused with this minus here is that particular one in here is going to be negated. So this means you won't have that. So you will have minus, minus, plus, plus. So you've basically now unbalanced the whole thing, because the elements that these were supposed to cancel with, they won't cancel with anymore. They will actually enhance themselves, right? So they'll have constructive interference. And this actually literally means that you're left with that, right? You're left with that pattern in here, but the zeros are still predominantly whatever it's called positive, right? So these one is negative, but there are three positive components to it in the whole thing. So you're still going to have that positive one. So if you take a look at if I take a look at the amplitudes after here, you're going to see that the amplitude of 0, 0 is still positive. It's still phase 0, right? And honestly, I mean, here it's pretty obvious that what you basically have is, you know, you're left with this element, which is kind of what you flagged, right? And so the only tweak that you need to do is you need to adapt the phase of the 0, 0, which is the element that is actually the seat of your superposition initially, right? So this element will be different if you start with a 1, 0, 1, 1, and whatnot. And that's also the reason why this is what you have inside your amplitude amplification, because that's just a correction. It's just minuses the phase of the 0, 0 component. So you end up exactly with something that looks like that, which is basically literally 1, 0 if you apply it the next Hadamard layer. So what am I doing? I didn't want to print that. Anyway, so I wanted to pause because I had to cough. So this is the right piece. This is the right direction. This is the right intuition. I think it's and it's interesting because even though I made a mistake in the last video, I think it's correct. And it's funny though that it seems the biggest contribution to the whole thing is the first layer of Hadamard's and not what comes afterwards. What comes afterwards, it's merely a correction. It's merely a correction. It's merely a correction of that particular element that's the seat of your original superposition in order to actually end up with the state that you want. Now, with with 3 qubits, because here you've got these 4 different possibilities, and so when you face one of these solutions, you're going to have that result already, where only that amplitude is the one that's left, right? And if you happen to flag another one, if the oracle happens to flag another one, say 1, 1, then we will see immediately that it already doesn't work. The reason is that, well, your playground basically is made of those 4 different possibilities, and so if you change the sign of another one, then basically the whole purpose of your trick here is gone, because this element that you're not creating it, you're not unbalancing anymore, you're balancing again, right? So the stuff, the elements that this would then constructively interfere with, now they don't again anymore, because you've also flipped the sign on another one. So I think that's correct. Now, when you have 3 elements, right, then you've got 8 possibilities, right? So if you've got 3 elements, you've got 8 possibilities, and then so now you can actually flag 2 elements. But it's the same. It's the same thing. I'm trying to see if I can link that to quantum counting somehow. Now, let's say that you flag the 1, 0, 0 and 1, 1, 1, right? So now it's becoming interesting. How could I do this? How could I better show this with Excel to list all the possible or Excel with Google Sheets. Sheets.neo. So you can do that, right? So because then you have like, okay, so you've got basically, I mean, I've got the numbers until 8, right? And so I can also play with the zeros and minus ones to represent the phases, because that's obviously zero, 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 zero for the case of, you know, so these I'll put the cat 0, 0, 0. So this is the cat 0, 0, 1. This is the cat 0, 1, 0. This is the cat 0, 0, 1, 1. This is the cat 1, 0, 0. Am I missing anything? I don't think so. I know I can copy those over and basically add these. Now I have got 3, 6, 7, 8. Cool. But now basically insert one left, one right, one left. Can I copy them? I think I can copy them like these, and I think I can do it like that. I'm not so sure. Whoa, no, but okay. Should probably transpose it or something, but all good. So, okay. So, my point here is, and I should probably do this with Python or something. It probably look like stupid. Good. So this is just, I know these numbers have the binary representation, but basically the way the phases would look like is probably like these, and then everywhere where you have a, in this case, -1, in this case, -1, -1, -1. I think that would be that particular configuration. Let me quickly check. Quirk. So the intuition here is whatever you have a 1 in the rightmost qubit, then you put a -1 in this case. The trick is where you've got the 1, 1 in here, then it's kind of either or, right? Because either or, because if you, because then the elements that will have 1, 1, this -1 and -1 will just cancel out. So this is gonna have, yeah, -1 everywhere where you've got like a 1. Exactly. So in here you're gonna have -1, -1, -1, -1. In here you're gonna have -1, -1. Here no, nothing, and then here -1, -1. And here's basically -1, -1, -1, -1. And here you've got basically here nothing because both are there. Here's either oh, so here's there. Here also nothing. Here yes. Here yes. Here no. Here yes. And it basically, it's funny because it's literally, I think you're basically gonna have, I mean, there are 8 unique states as well, right? That's also, you're encoding these numbers into the phases of your superposition. Um, so 1, 1, 0, that means here we got 1, here we got 1, here we got 1, here we got 1, here we got nothing, here also we got nothing, and then 1, 1, 1 is basically, yeah, well, it's basically only going to be here, it's going to be here, and here, honestly, right? Let's double check that I didn't make a mistake anywhere. It's 0, 0, 1, 0, 1, 0, 1, 0, 0, well, 1, 1, 1, so I did make a mistake. There's always going to be 4 minus 1s in here. Okay, so that's basically it. Instead of drawing it here by hand, because it's going to be too much, I'm going to have enough space in here, I guess. But basically, I mean, let's go through the case where we flag just one of those, right? Can I zoom in? Got it. No, I wanted to zoom in a little bit. So it's ugly, but anyway. Let's say we flag this element, right? So you're literally going to have, so if you flag this element, right, with 180 degrees, you're literally going to have the inverse of these, right? Let me copy it here below the original so I don't mess up. So you're going to have, so I can 0, 0, minus 1, minus 1, 0, 0, minus 1. And so, again, the zeros shouldn't be zeros, should be plus 1s, honestly. Should be 1s. Okay. It's easier this way. I mean, easier. It's not easy to see, but it's easy to. It's easy probably to then take a look at how these things interfere. That's my guess. You see, that would be cool if something like that would be in Quirk. I think I might work on this, maybe extend Quirk to have some sort of interference inspector or something like this. Because now basically, now basically, as you can see here, right? So they were all positive, but now there's one that's negative, right? So if now I apply Hadamard, it will literally be to add up these things, right? That's how you now would basically say the effect of interference would be in the column J, right? So this is the interference result. And so this would literally be the sum of these things, right? So you can see it's positive. I'm only interested in the signing here. 2, 2 minus 2. So you see the pattern, right? So it's there's been some constructive interference in here, negative, constructive, but like still constructive, and so it basically the pattern here of I should basically do this. What is this modulo 1? I want it, but anyway, so basically you can see that the pattern of positivity and negativity is the same like in here, with the only exception that this element is negative. So it's the same story, right? You're literally left with yeah, you just have to tweak that sign over here for this to be like a -6, so to say. Um, yeah, so that basically now you have the same pattern like with these. So when you apply the Hadamard's, so well, that's really what you get. Oh, wait a second. Not entirely. Mm, things cancel out. Things cancel out. So let me think about this for a second. Let me think about this for a second. Which one we found? 0 and 1, right? So let's say that we do this. We do it this way. So that's what you should be actually left with. Mm. So you're left with this pattern, which is the pattern that you're only missing this little tweak in there. Exactly. Uh, okay, but the intuition here is a little bit different, right? So because we're not left with just that element. So, but we can see these here because we don't have ones and plus ones and minus ones. I think that's the point. So there's way more of this element. Yeah. If I would scale that down to the 2-qubit example, I would just have zeros in here. So they haven't really, okay, so they haven't really canceled out, but it's the pattern of, but if you pay attention, it's that pattern, right? So that's also why intuitively you've got that pattern left over here. And now when you apply the last layer of Hadamard's, it's gonna almost, so I would say intuitively, because, like if this would be an equal superposition, you would basically just get that element. But because it's not an equal superposition, you're getting almost that element, and the rest kind of stays spread out in here. But the phase is all like, it's been all, look at these. There's a global phase of 180 degrees. And this is something you could read out with the QPU, with the QPE, with the quantum phase estimation. And that might be the link to quantum counting and why quantum counting works, because this one solution in here adds a global phase of 180 degrees. So, but this is the, so, but this is a way to see it. So there's two things in here that you should see as a result. One is the pattern of positive and negative phase. So one is the phase pattern, another one is the amplitudes, right? The phase pattern will actually tell you where most of the amplitude will go. Yeah. That pattern that's left here tells you where most of the amplitude goes. Because at the end of the day, it's intuitively what's encoded in the superposition and in the phases. This is it. This is the 0, 1, 1 state encoded in the phases. It's just that it's not equally distributed. Yeah. And so that's where this is going to go. This is the so that's a nice enhancement to my intuition, I'd say. That's where this goes, because the state 0, 1, 1, it's encoded in the phases, in the phase. But the superposition is not an equal one. Is it called equal? I don't know. It's not balanced. It's not like equally distributed. Equal distributed. Okay. Yeah, I think that makes sense. And here the same logic applies. The more of these items we flip and see what happens. Let's say now, for example, that we also want to flip this one, right? So we're gonna say -1, +1, -1, +1, +1, -1, +1, -1. So now we see here there's a different interference pattern. Oh, I'm liking that. I'm liking that. So I see a different interference pattern in here now. So basically, 4 elements are completely destroyed. But now, what is encoded in the phases? So we've got negative, negative, positive, positive. So have we got anything? So those two things share the fact that they are negative, negative, right? But can you intuitively say that? Well, you can, because I mean, it seems to be like that, because pay attention. If we, so what if I do the sum of these? Just give me a second. So that should give me, yeah, that gives me the same pattern, but opposite, right? Opposite. Huh. Same pattern, but opposite. So what have we? Which element have we flagged? 1, 0, 1. 1, 0, 1. Yeah. Oh, wait a second. Exactly. So the only difference between these two elements, these two superpositions, is that you need to tweak this one here. Sorry, here. You need to tweak it here. And then you end up with the a second, because here we've got, let me remove these. So here we've got, so if I applied a Hadamard to these, I'm gonna get these exactly. So the superposition that's got these as a seed, it's these, but the opposites. It's 0, -1, -1, 0. Exactly. Okay, so yeah, it's the 0, -1, -1, 0. I mean, not once, but like that's the pattern, but it's the inverse pattern. It's the inverse pattern of these in here. So that's actually something that uniquely encodes these two elements, I'd say, because there's no other combination that sums up that can actually give you this pattern, literally. Because you need to have, it's almost like an XOR, awfully feels like. But I think that's correct. That's what you end up with, these two elements. And the thing is, but what I'm not happy is that this is not telling, it's not giving me what I expected, as in like it should be equally balanced. So why is this -6? Why is this -6? That bothers me a little bit. Because I wanted this to be -4. I'm not liking that very much. Um, because let me remove this, because I've basically changed the sign in here. Hmm. Hmm. Well, wait a second, something's wrong in here. Oh, here you go. No, it's plus plus. It's plus, yeah, okay, it's plus plus, yeah. You see, got it right. It's plus plus plus, but that's the one correction you got to do. So you got to basically, I had a -6 because I had hard coded it before. So what you do here is you're gonna have -1 times these. What the hell? -1 times these, and the rest is basically these. Yeah. So that's your actual final state. Yeah. Nice. I like this way of seeing things. This should really be a thing. Um, and now if I say, let's keep flipping elements. Let's flip this one now. So it's going to be -1, 1, -1, 1, -1, 1, -1, 1. What have we got in here now? We've got this pattern, which again, it's probably the combination of these ones in here, if I do understand this correctly. But opposite. I mean, I don't know, I'm taking a look at this, but basically these unique pattern of phases identifies the superposition of 001, 011, and 101. So how could I prove that? How could I prove that? Well, I mean, the proof is that if you apply Hadamard's to these, so what did I flag now? 001? So I'd say 001. So if I apply, because that's not totally true what I just said here. So this is something that I'm missing here to refine it intuitively, I think. That basically, so I've changed the phase of this element. I changed the phase of this element. Change the phase of this element in here, and so this means that those things won't interfere anymore destructively, but they will do so constructively. For example, you know, here, this with this one, this with this one, this with this one constructively, and then the rest will just cancel out, right? And so you'll basically have it's almost like you'll basically have that combination of elements. So you're gonna have that combination of elements that basically is uniquely identified with us with that phase pattern. I'm just interested in the phase pattern. How could I check these? Just interested in the phase pattern, honestly. So if I could create a superposition that just has these three elements in it and nothing else, then and then I apply Hadamard gates, then you would get that particular. How can I do this? Can I do this? With entanglement somehow? So you start with your superposition. And I basically wanna, how would I entangle that in a way that gives me that? Is it, there should, is, is there a way to do that? Systematically, there must be. I mean, I can make one example that it's easier that I kind of know more about, which would be these and these, right? So let's say this state, right? So we've got 0, 0, 0, and 1, 1, 1. So let's change our, let's revert all these. Go back to the original state, go back to the original state, go back to the original state in here. So we undo all the colors and get done with these. So now we're back at full 0. Now let's change the state. This one, -1, -1, -1, -1, -1, -1, -1, -1. So obviously I forgot to keep it here so I can revert it later. That's basically all ones. And now this state in here, which is going to be basically -1, 1, 1, -1, 1, -1, -1, 1. And so now you've got, what is the phase? So it's all negative. Interesting. Something's 6, -2, -2, -2, -2, -2. Well, it's all negative. If I apply a Hadamard to these, that's not what I get. Okay, so here this is somewhat failing. Maybe because yeah, I mean, it should actually be am I doing something wrong? So I'm flagging 1, 1, 1, and then I'll flag the 0, 0, 0. Which, in order to do so, you've got to basically do this trick with the X gates. I'm definitely doing something wrong. I think I haven't. Oh, I think I messed up with the elements I flagged before. I think I copied over the same thing. Did I? So -1, -1, -1, -1, that's correct. So +1, -1, that's not, that's -1, +1, minus, no, plus 1, minus 1, minus 1. That's correct. Mm. Or, wait a second, I think I changed it in the wrong. So that's correct. This here is correct, 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 correct. This here is basically correct. So where am I missing something now? That's not, am I missing something somewhere? Hmm. If I'm flagging the -1 and the 111,000, and after the first Hadamard I should get this pattern. So some things should cancel out basically, but they don't. So this cancels out, this cancels out, this cancels out, this doesn't. Well, I haven't flipped that sign here, you know? I flipped it here. Oh my god, I'm so stupid. I'm so stupid. So, yeah, now we're talking. Good, now we're talking. And exactly that's what I'm saying. So you've got the opposite pattern, yeah. If I now flag a third element, say 100, right? Yeah, but how can I create another superposition with a third element? No, what if I... How to create a state? I think it was called GZ, Professional GZ state, 3-qubit GZ separation circuit images. These and these, okay? These and these, no. Oh, and still another Hadamard. Oh, now we've got 4 elements. Okay, that's cool. That's cool. Let's see. No, but I don't want 4 elements. I want 3 elements. Can I have 3 elements? Can I just have... Because there's always going to be 4 elements. So that's giving me these. It's basically this state. Tangled state with 3 amplitudes. That was not really helpful. Or maybe entangled state examples, 3 qubits. Come on. It shouldn't be complicated because I'm saying Hadamard. Maybe I should put another Hadamard in here somewhere. No, it's the same. We end up with things like these. I say Hadamard, and I say if this is a 1, 0, and now maybe if I do 1, 1, 1. Do something like that. That's not what I want. That's not what I want. It seems it's only allowing me to do a power of 2. Yeah. Anyway, I'll see if I can figure it out. Because I'm going to do a second video anyway on these and on the connection with quantum counting. But basically, that seems to be the idea. So this particular combination of phases, the opposite, right? Like, is basically encoding these 2 elements. Yeah, it's basically encoding these 2 elements. So what I wanted to prove is that for a third element, right? Say this one here. If I do this, then basically I want to take a look at the pattern of interferences in here, pattern of phases in here, and then basically arrive to the conclusion that okay, now most of the uncertainty most of the certainty is here, but because this phase pattern particularly encodes these 3 elements, this is where this is going to be distributed towards when you apply the next Hadamard, because the Hadamard moves it from one encoding to another. That's my point. Yeah. But I want to be able to create 3 I thought that shouldn't be. Anyway, what's up with the phases, with the global phases though? Here we've got a global phase also of 180 degrees. If I add another element, now it's already messed up, right? Now you've got a mixture of things I cannot add more elements, because if I add another element, then flying another element is not going to work. So I'll probably, in the next video I want to try to understand how does the global phase evolve. So I want to basically compute the global phase for as a function of the elements we're flagging, because I think this is where the relationship is going. Because definitely one element seems to add a 180 degrees global phase, but 2 as well. So I don't know. And 3, it's a funny thing what's happening here. Oh, wait a second. It's maybe not that funny. It's not that funny. Look at this. Oh, it's adding, no, it's adding, maybe if you think of this as cyclic, this is adding twice 180 degrees. So 2 pi, because we're doing it in respect to this element in here. Are we or not? Is it in respect to this element? If we flag 2 elements, then I don't know. If we flag 3 elements, 1 element, That's not, it's rather in respect to this element. So what's the global phase added in there? How can you compute, how can you then do that? If we say reflect randomly 3 elements, right? How can I compute what's the global phase now added between here and here? Can I know these? How can I compute these? That's a question for the next video. Good. What's the global phase in here? Because that's going to connect me to quantum counting. Because this global phase is the one that gets passed up with a kickback with when you control Grover's iteration. And that's what I want to get into from an intuitive perspective. But okay, so I just wanted to validate my thinking was correct, and it seems like so. I like the way to visualize these things here with interference, sort of an interference inspection in here, and I think I kind of like that. So what did I learn? Basically that this little thing in here is just a correction. It's really just a correction. Most of the work happens here. You're just here correcting, we're correcting for the state, that's the initial state of your superposition here. So that you end up with a pattern of phases. So they end up with a pattern of phases that encodes exactly the superposition of elements that you want to have, which is this one in here, right? But because your amplitudes are not equally distributed, then you end up with something like that instead of just these elements, because it's what you really ideally would want, right? I don't know. Is that helpful? I feel that's intuitively helpful. So the key fact here is that with the Hadamard gate, you're encoding your state into the phases of the superposition. Yeah, that's the key. I wonder if you can derive think about the average inversion that the geometrical interpretation is based on, but using these intuition. Yeah, that's worth thinking about this. So now we know how is the interference working. I want to know more about the global phase, and I want to know more about whether I can infer and sort of derive how much of that uncertainty is being distributed and why. It's got to do with the number of elements you flag, definitely, because that defines where the 6 here is, right? Yeah, not bad. I think not bad. Definitely not bad. I'm trying to think if this is been enough in the direction I wanted to go for this video. I think so. Validated these. Yeah. The Hadamard is where most of the work is happening. Basically. Because you know you're basically unbalancing your superposition towards the elements you flagged. That's basically what you're doing. So I find this much more intuitive than just thinking about rotations, right? Or thinking about a geometrical rotation that's getting closer to the element to the solution you want. Maybe I should try to think, how can then I intuitively apply that to a second iteration? For this, I probably need 4 qubits. And for this, I probably need a more serious interference inspection tool here to take a look at how this is actually evolving. Yeah, but even with 4 qubits, it's gonna be quite big. Okay, cool. I should save that. interference inspector. So this is Grover, 3 qubits. Cool. Perfect. But that's the key. That's the key. You're encoding stuff in your phases in the superposition. That's what you do with Hadamard. And then if you change some of those phases, then you're basically breaking that balance. Yeah. Yeah. And because you're breaking that balance, you end up with, so things cancel out, and then you end up with a pattern that basically encodes those elements you're flagging. That's what's, I'm not sure if I'm not making sort of, or assuming something in here that I shouldn't, but got to think about this a bit more. But I think it's the right direction.